Capital is abundant. Understanding is scarce. The Dynamo Show goes deep with the new industrialists rejuvenating industry and commerce. Brought to you by Dynamo Ventures. Learn more at dynamo.vc/podcast. Now, here's your host, Madelyn O'Farrell.
Hello, everyone, and welcome back to the Dynamo Show. I'm excited to be joined today by Jay Allardyce. Jay, thank you so much for joining.
Madelyn, thank you for having me. It's a pleasure to be here.
You are Chief Product Officer at Octave. And for our listeners, I'd love to just first dive into a little bit about your story and how that led you to Octave, and then maybe we can talk about Octave itself.
Okay. Well, great to be a part of the conversation with Dynamo here. So about myself, yes, I'm the Chief Product Officer of Octave. Been about 8 months now, I think, into the company. But heritage-wise, for me, 25 years in tech. Started my career in Silicon Valley, worked with Hewlett Packard for a number of years, worked with some startups, and then eventually through that career comes an M&A, new ventures, and then went into our enterprise software division for a number of years. But then left and went to GE. You know, it was a time that I think many of my mentors and colleagues said that it was probably the worst decision. I look back on it as one of the best decisions. GE is a storied company, great culture, great individuals, great mission. But for me, I got bit by the bug at HP where we were doing some real-time energy management out of data centers and tried to understand how you could bring the data together to help everybody, citizens, to understand what they consume, use, and waste relative to natural resources. So I got bit by the bug of how could you take data to a real-world problem that affects millions of people. And so anyways, my time at HP kind of led to then GE, as I mentioned, and it was one of those of, wasn't recruited. It was an opportunity to go learn with one of the best. I said, hey, if I have to learn this industry, where can I do this? And so the fortunate opportunity to go there, help build a digital business in the power and water space. So dealing with, different generation activities of coal-fired plants to gas plants to solar plants, transmission distribution. And so I did that for about 3.5 years. I was a COO for that business and then became Chief Product and Marketing Officer for a bit with GE Digital. And then went to a startup called Uptake that's just recently in process of being acquired by Bosch. So big kudos to the team there. But that was all around machine failure. So predictive analytics, trying to understand why equipment failed, how do you prevent it, how do you have more prescription around it? Because every bit of downtime is cost, it's waste, impacts the business. After that, a couple other stints, spent some time at Google for about 3 years in Google Cloud on the partnership side, and then enterprise AI ML. And then had a stint in a private equity-backed company called Insight Software for a couple of years before I came to Octave. And I think for me, culminating, if you will, was I like to say it's a bit of a homecoming. I have seen a lot of these patterns of potentially spinning out a business, refactoring a software portfolio, building platforms. And so coming into an industry that I care for and see tremendous upside with going forward, this is probably the best match there is. So super excited to be a part of the team.
Amazing. Well, thank you so much for giving us your background there. And tell us more about Octave. What exactly are you guys building?
You bet. So I'll give you some context of Octave. It's been a part of the Hexagon portfolio, and we have assembled the software assets that go across a lifecycle from design, build, operate, protect. And what that really essentially means is if you think of all the large construction out in the world, everything from power plants to roadways to bridges to buildings, we build software that supports those EPCs, so engine procurement and construction, very large construction builders, to actually go design, build, and hand over those assets to operators. Then you also think about it through that line in the operate side is someone has to run it. So whether it's a power plant, whether it's a building, whether it's a fleet of vehicles. So there's a tremendous amount of software that supports how you operate those environments for better predictability, maintenance, and overall operating improvements. The last is protect, which is a mixture of a couple things. One of which is industrial cybersecurity, as well as how we think about inventory management within our operator environments, so the assets that people have within a power plant. But one of the really cool things as well is what we do is public safety. So 1 in 8 citizens on the globe are protected by our software. So in the US, you call in a 911. Perhaps it's powered by our solution called OnCall. So the routing and dispatching and the service of helping to help any citizen in distress, and then being able to coordinate across different agencies, our software helps to do that. And so in this life cycle, we think of that value is created at every one of those stages, but a tremendous amount of value is lost in between. So you design something, and then the next person has to think about how they're building it, to the next person thinks about how they're operating it. And oftentimes things don't really move throughout that life cycle continuum. So as a company, we're about $1.6 billion in revenue, and we are in process right now to be dual listed on the Swedish stock exchange as well as the NASDAQ here in May. And so as a public company, we're in service of really helping this built environment to become, I think, far more efficient as we go forward in this world of AI, data, and the physical world.
Fantastic. Well, first of all, congratulations on the upcoming public listing. And if I recall, there is an interesting sort of background or intersection with Formula One. Can you tell us a little bit about what that entails?
You bet. So, many people will think about partnering with F1, which is a great platform to partner with, but oftentimes it's around the car or it's around the brand. And for us, we had to look at this a lot more broad than that. We think of F1 as a traveling city. They go from event to event, and they're moving cars, they're moving people, they're moving, potentially customers, folks that are going to the events, and all the logistics and all the material to make the race effective. So the behind the scenes is 100 times more complex. Some will probably say it's even more complex than that. And so we've partnered with the Visa Cash App Racing Bulls. And it's really exciting because it's an organization that is innovation at heart. They are technology first, and they're all about building an experience that is captivating an audience, but through precision engineering, whether that's the car, whether that's the manufacturing of materials, whether that's the operations. And so they have a very dedicated staff globally that are helping to manage not only at race day, but throughout the entire year itself. And so couldn't be more excited to partner with them because it's helping us think about the technologies that we make in support of customers in probably one of the most complex moving scenarios, which, as we're talking about here about supply chain, is near and dear to their heart, and it's something that we think we've excelled at over the decades.
I am admittedly not an F1 aficionado, but I will admit I certainly understand that it is all about speed and precision. Can you tell us more about what that supply chain in F1 actually looks like and why you think it's a model for broader industry?
You bet. Well, maybe if one goal I have, Madelyn, is to have you become a fan of F1 at the onset of after this. It's interesting. It's if you think about how they operate, an F1 car has precision design to operate in some of the most extreme conditions, and so many of these parts are built, they're designed, and they're manufactured at their sites. It's not as if they're going to get a general SKU that says, okay, here, this piece of a wing is going to be procured from a particular vendor. And so with that, there's a tremendous amount of design. There's the pride in how that's all built. So as that material comes together at every race, the amount of precision and feedback on how a car has worked, how it's produced, the simulation of that, then forces into the design. And oftentimes, as in many parts of our business, as we see with customers, you have this great design and then someone else is manufacturing it, then someone else is operating it. At each of those handoffs, the context is missing. So the person that really knew how things were designed has a great passion for what they built. But the person that is manufacturing says, well, lowest cost, lowest price, I need to get out the door to manage my margin. Well, that's all done. And then you have someone that is operating it. They may have a very different viewpoint. But in the case of an integrated supply chain for F1, in the case of Visa Cash App, for them, it's all the way through. And they have to think about it that way. And so that's going to be materials, the type of materials being used, how it's been designed, how it's been simulated, how it's been transported, the logistics of it for the next race. How many of those do they have to have on hand? When things have then potentially gone wrong, what data are they using to analyze potentially the defect of that material? And how does that come back into the design? So it's kind of a round trip. And the more that can be done, you're effectively creating a simulation of a digital twin of not only the car, but a piece of equipment. And it's not just around precision engineering, but it really couples in together the supply chain and the availability of types of material that go into building that unique piece of equipment.
This digital thread that you've just outlined for us, can you tell us more about what it's really costing companies that aren't paying attention to it?
Yeah, this is tremendous. And I think it varies depending on the industry you're in and the market you're in. But we think about it that for every point down the line that is being passed, it is anywhere from a 1x to a 10x impact of value. So as an example, if the person that's manufacturing the piece of equipment truly understood the design and didn't just take a schematic to then go print what they needed to do, but actually understood the intricacies of how that happened, then you might actually produce one component and be fine. You didn't have to do multiple manufacturing runs. So this constant loop of that. On the operate side, it's, many times you produce something and then you put it in the setting being the race in the car, and find out this doesn't work. And so then you're back into the manufacturing of the design. So if you can constantly have this kind of controlled loop that's giving feedback all the way through, the ability for someone who's taken that precision engineering to the point of race day and knowing that it has a 99.9% of working to spec minus a crash or other externalities, that's where value is created. So we like to think of it that way. And if you take that into parlay of any of our large customers that are constructing, I'm here in New York City and see a significant building that is going up, that's a lot of money to have to redo something. And so if you get it right at the design time all the way through, I think it's a great demonstration for F1 because every second counts, and the cost of maintaining these environments is significant. And so the value is tremendous, and it varies depending on customers and how they operate.
That absolutely makes sense. There's a concept in racing that you have to finish to win. And so reliability really comes before performance. How would you articulate the way that ties into supply chains?
Yeah. So when you think about reliability, there's multiple folds in the sense that a piece of equipment, you're going to look at how that piece of equipment is performed relative to the rest of, say, a car or a building. So it's always an association. You have to have context that maybe this particular flange continues to fail. Well, is it because it was poorly manufactured, or is there a stressor because the way that contact was built is how it's attached? So if you don't have the context of how something is performing, you're going to look at a precision of reliability on a singular piece and actually miss the picture. So the ability to kind of step back and say, from a design and a build perspective, where does that piece of equipment fit relative to the rest of the machine? And when you understand that, then the design has a true efficacy for its type of reliable performance, if you will. And therefore, everything is in concert. So I'll give you another example where if I look at a large building outside, it has to match a design of that building itself and all the material that goes into that design. If something changes in the design, the material might have to change and vice versa. So the reliability really starts at the design principle for how something is to be manufactured, whether that's a piece of equipment on a car, whether that's a roadway or a building. And that is a tremendous value differentiator for any company to manage costs, but have greater reliability of how that might actually perform in race day in this example.
You talked about these processes and systems kind of working in concert with one another. What do you think it practically takes, both technically and operationally, to create these feedback loops so that they are working together?
Yeah, this might be a whole segment into itself. But what's kind of cool with this is, we would always say in technology, and I think we still do today, is with, people process technology. With the advancement of AI now, in particular generative AI, if you don't have context of how something works or how it operates in its setting, then you're missing multiple parts of that story. So for an organization to think about this, typical would be, I'm going to rush to, oh, I have all this data. Let me see what's happening. What signals are, faulting because of this particular piece of equipment or this particular approach. But that lacks, again, the context of, well, I have this car in this setting, in this particular situation. How did it perform? Well, what are the externalities with that as well, which might be weather, it might be road condition, it might be, Mother Nature, back to the weather topic. So all these factors come into play. And so step one for someone is to take a 360-degree view of an asset. And in that situation, you want to look at how it performed, which could be a power plant, it could be a building, it could be a race car. And when they have that full picture, then you start to ask questions about how it's performing, because you understand it's in its setting. Well, it's been raining this week. We've used different tires. We've had a different type of material happen. We had this backup spare that was in place. So all these factors come into play. And so much so, then you can recreate, if you will, a digital twin to understand the behavior of how that thing operated. So I would say in most, for many, instead of rushing to the data you have, step back and look, first principles, how is that operating in the environment that it is? And then map out what problems are you trying to solve in support of understanding that. And then third, what data do you need to actually answer those questions? And that's kind of probably the most simplistic way to approach it. I think so many companies come at it with, let me just understand with all the data, what is it telling me? That's not bad, but you leave a lot to be understood, which is the context of how it's been performing or operating in its setting.
For someone who maybe wants to adopt the playbook that you just outlined, what would you say are maybe some potential bottlenecks that they might face in building some of that visibility infrastructure?
Yeah, I mean, one is going to be recency bias. And so what I mean of that is we're all creatures of habit. We learn something, the muscle memory, the patterns, and it's hard to step back and say, well, wait a minute, let me reframe the question. If I understand where I'm sitting, you might have a tendency to look at it through the lens that you're comfortable with. So that is the hardest, if not the most difficult, because, as humans, we build repetition based on what we know. The second is, if you think about data, it's going to be incomplete. I will start there by saying that someone's going to say, well, I have, we used to always say in the power plant side of the world, to say, okay, well, I have work order data. Well, that's important. It's interesting, but it's not the full picture. What are all the additional data sets that could affect the performance of that piece of equipment? So what is the 360-degree view of it? And then the second is going to be the infrastructure, technologically. So many technologists want to be the one solving the hard problem, and they will go after it and say, well, I'm going to spin up this environment. I'll build this vector graph. I'm going to go do, so they have a very singular view based on what? Their bias. So if you can make sure you answer those first two questions, then you're starting to work and say, what infrastructure do I need to have in place for this? Because I think there is a strong appetite to say, just put it into some sort of AI, Claude, GPT, pick whatever. But without truly understanding the problem you solve, you then have a very difficult time challenging what information is coming back at you because you're not grounded. So you got to be grounded in that context before you even touch the environments. Is just, I would say, one of the more advanced ways to avoid a lot of cost and rework and perhaps, feeling like something didn't work.
Absolutely makes sense. You alluded to kind of ChatGPT, Cloud Cowork, some of these other tools. Where have you found external tooling to be beneficial as you all have undertaken this yourself? And it could be kind of these general AI platforms like you talked about, or maybe it's elsewhere.
Yeah. So I'm a big fan, and not to promote them, not like they need more promotion, but Anthropic. I truly appreciate what that team has built in terms of safety and guardrails and being mindful of how information is actually retrieved, to create a bit of that boundary versus, what you get. If you're not able to discern it, you might simply just take and run with it. But it gives you a lot of thoughtfulness of what you're seeing and how it comes back to almost pose the question back to you to really reinforce a human in the loop interaction. That is super important going forward, because if you think of the environments that we're in, especially, younger individuals, they will take it first glance and go, oh, I put it in here. Here's my answer. Well, as we see, we're getting a tremendous amount of AI content out there. You're getting a tremendous amount of I would say, more highly leveraged, documents being created because of AI. And so then you ask yourself, like, okay, I no longer trust this, so why should I engage with it? So there's a real danger in that regard. So I would say for myself, I really appreciate what Anthropic is doing, but across different models, whether that's from Meta or Grok or from OpenAI, they all serve a great purpose based on performance and weighting, and also just the type of responsorial. So it's kind of in some ways based on a use case, what works best for a situation. But I would say one of the biggest resources that is I would say probably underutilized the most is all of us in society are having to go through a retrain. So back to this, don't anchor on the bias you have, but think of this as if this is the first tool you've ever interacted with. What questions would you ask? How would you actually have a very different conscientious approach to the work that you do? So I think there's a tremendous set of just in society that we have to learn far more than just simply accept the tool, because it's forcing us to do one great thing, and that is kind of the creative thinking and approach of asking the right type of questions to really unlock the power that I think many have not yet grasped that it can do.
Absolutely. If companies were to get this right with kind of the playbook you outlined, some of the tooling that you've mentioned that can be so beneficial, what do you think these supply chains look like in 5 to 10 years?
Oh my goodness. I'm trying to think of the phrase I was using for quite a while, but there's this notion where you have an anticipatory nature. So what I mean by that is every node in a network has some sort of signature and understanding, but the association of that network, the context, actually creates a pattern or a system that then therefore can be dynamic. And so it can anticipate needs. And with that, I think there's already great examples of how that's happened in the consumer world, where dynamic pricing, availability, time to deliver, not to name those companies' names, but they've really helped to solve that because they looked at the supply chain in a network. They looked at entire context to say, I have a buyer and seller, I have price, I have value, I have time, I have distribution, I have all these things that might factor the ability for me to price it at some point and give you the best experience because it delivered on time. So that is system thinking just at its core. But with that approach, I do think that people can spend with an understanding of what are those inputs, what are some of those challenges, a way to, build software first. There's a lot of discussion around a software-defined supply chain, just as there's a software-defined network or software-defined manufacturing. There's a complete reframe of how you're building a good, in the case of what materials are needed in support of that would redefine how manufacturing is done. So there's some great leaders out there talking about that. So I think in that regard, there's a lot more connectedness that is not simply a supply and demand matching, but is something that you can be much more anticipatory because work is done agentic first, helping to solve some specific problems in the network, but therefore not degrading the experience that you would expect if something was to be built or delivered that you were looking for.
Well, Jay, thank you so much for your time. Again, really appreciate all of your insight. And to our listeners, thank you for joining us here at the Dynamo Show. We'll see you next time.
Sounds good. Thank you, Madelyn. Thank you for having me. Pleasure.
Thanks for listening. If you enjoyed this episode, leave us a 5-star review and tell us what you liked. And be sure to head over to podcast.dynamo.vc to keep up to date with our latest content, or subscribe on the podcast platform of your choice. Until next time.